So this example refers back to the comment that was made in the Avonford Star at the start of chapter 3. Basically, he's found that the usual level of this is 328 parts per million, and a sample of 10 specimens of Avonford are collected and the carbon dioxide level within them is determined, and the results are as follows. Now, when you add up all of these numbers and divide by how many there are, you'll get the mean of these 10 samples, which, if I just cheat and find the answer, comes out to be 331. So, on average, we see that there's 328 parts per million. We found in our sample of 10 there's 331 parts per million, and we're going to look to see if this is out of the ordinary. Now, an extensive piece of research has shown that the standard deviation of such samples is 2.5, and the distribution may be assumed to be normal. That's very important. When you're dealing with a sample of only 10, it's not really enough to say with only 10 that, oh yes, I can see the distribution is normal. You need to have about a sample of 50 if you're going to say it is normal. So the question should state it is normal if the sample size is less than 50. If the sample size is over 50, then it might not need to necessarily state it. So use the data to test at the 0% significance level AMA's belief that the carbon dioxide in Avonford is above normal. So we're doing hypothesis testing, which is very similar to the hypothesis testing we do in Stats 1. We're going to have a look at basically where we are originally and then where we want to be. So there's 328 and there's 331, and in essence we know that's a good level, and we want to find out, is this a bad level or a good level. Now, I've not done any other numbers in here. It doesn't quite like the binomial one, but in essence we are going to do the same thing. I want to know, is my 0.1% on this side, at which point I'd have a cross, or is my 0.1% on this side, at which point we'd have a tick. And everything is going to be revolved around that. So what we're going to do is, let's just make sure I've got an eraser, which I do. We're going to have our normal distribution. Now remember, when you're setting up your normal distribution, you're trying to think about what the question's asked. And here our variable, which I'll call x, is normally distributed with, on average, 328 parts per million, and it said a standard deviation of 2.5, so my variance is 2.5 squared. Now my hypothesis is, initially the mean is 328. Always assume the mean is exactly what you expect it to be. Your alternative hypothesis is that, and the key word here, belief the level of carbon dioxide is above normal. So mu has to be greater than 328. And we're just trying to find out if this value, 331, matches that. So we're dealing with a normal distribution, so in Blue Peter style, we'll have a little scale up. I know that the mean is 328. I know I've got a value of 331. Now I tend to like to do this with standardized scores. So what I'm going to do is just convert my standardized score, my 331, into a standardized score. So 331 minus 328 divided by 2.5 it was. And so my standardized score for this value comes out to be 3.79. So that means that's 0 and that's 3.79. Now I've got a couple of choices of what I can do. In the binomial, if you've had me, well, you have had me as a teacher. If the year after, no, you might not have. In the binomial, what I like to do is I'd like to find the critical value. So find that dashed line where I say this is where the 5% is, or this is where the 5% is, and then compare it. You can do that, or you can use your tables to find this. Now I'm going to find, and I'll do it in purple, I'm going to find the 0.1 significance level from my tables. Now remember, 0.1 significance on this diagram is going to be above. So I want to find out, is it above here? And my tables don't provide me the above value. What they do, that's an awful diagram, what they do is they provide me the below values. So if I want this to be 0.1%, I need this to be 99.9%. So I'm looking for the value 0.999. Now, that means I need to find my Z value. So I want phi of z being 0.999. So I'm going to need to use my inverse tables for this. And sure enough, look at that. I think that's my inverse tables. Yep, because there's my probabilities. It's either that or this one. No, they're my z values. So this is my inverse table. And I'm looking for 99.99%, which I don't have on the screen. So let's get the actual formula book up, and I'll pull. There we go. Was going smoothly. First videos of the day. Never go brilliantly. So P on this side, I want it to 99.9%. So there's 99%, 0.99. Then I go along the top to get the 0.09. So it's the very bottom right that I'm looking for. And there is my value, 3.09. So I know that Z here is going to be 3.09. Now, you could have looked up the 3.79 in your other table. So the 3.79, but unfortunately my table, and let's just move this because you can't quite see it, only goes up to 3.4. So I'll not get the 3.79 there. So at which point what I'm going to have to do is what I've done, 3.09. And 3.09 on my Z values comes out to be about here. Obviously this is not to scale, don't worry about it. They don't need to be to scale. So that means this area that I'm highlighting up here is 0.1%. Now clearly you can see that the 331 or standardized score 3.79, that lies in this area here, which means effectively it's not in my safe zone. My safe zone is anything in this side here that I'm highlighting in yellow. That's safe. Anything on the green side isn't. So my summary is that H0 is now going to be rejected, and I'm going to accept H1, and obviously my conclusion is that, and let's just get back to the question, and don't forget to write your conclusion. At the 0.1 significance level, there is enough evidence to say that the carbon dioxide level in Avenford has risen above 3.28. Or just risen, will be fine. And so you've got to put it not just in context of the maths, i.e. H0 accept, or H0 reject, and H1 accept, but you've also got to put it in context of the question.